Hi, this is Ms. DB, and in this video I'm going to show how to do a few of the problems from the 6.6 worksheet on properties of kites and trapezoids to solve problems. There's another video that includes all the notes and more examples, so this one's a briefer video. To start with, just a review of the theorems. If a quadrilateral is a kite, then its diagonals are perpendicular, so they will cross at right angles. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So we'll need to remember those theorems as we work with the problems on the worksheet. All right, to start with, let's look at number 1. It says that in kite ABCD, measure of angle BCD, this angle right here is 98. Come on, pen. Pen didn't want to grab there, but I think I got it now. Measure of angle BCD is 98, and measure of angle ADE, which is this piece, this part right here, is 47. And we need to find, for number 1, the measure of angle DAE. DAE is this angle down in the corner here. Now, we just looked at the theorems that said that these diagonals are going to cross at right angles, which means if we just focus on this little triangle down here, that we know 2 of the angles and we're looking for the third. We know that this one up here is 90, we know the bottom one is 47, and we're looking for the third. So we'll just use the triangle sum theorem, which says that if we can take 180 minus 90 minus 47, and we'll find the missing angle measure. So that one's not too bad. Let's look at number 2. This one's a little trickier. So we're going to be using the same picture. I'm just going to erase. We're not looking for this angle anymore, and we don't need that 90 degrees there anymore. Okay, so in this problem, let's look at what angle we're looking for. Measure of angle BCE. We're looking for this angle right here. Now, some people mistakenly just take 98 divided by 2. That's not true. You can't do that because we do not know that the diagonals are bisecting these 2 angles that are opposite each other. We do know that these 2 angles are equal to each other, which might be useful. Let's see, what else do we know? So this is 98 here too. We know that we have a quadrilateral, so the sum of the interior angles will be 47. We know that triangle ACD is an isosceles triangle. This might be helpful. This is an isosceles triangle down here. So the base angles are equal. And we found our answer for number 1. You should get 43 for this one. So this is 43, which means that this up here is also 43 degrees because base angles are equal in an isosceles triangle. So now we can take 98 minus 43, and we get our answer. Now, if you read through these notes that I pasted here, this was a more complicated way to find that answer. This would be a more straightforward way to do it. Okay, let's look at number 3. In number 3, we are looking for the measure of angle ABC. That's this angle up here. Now, to find that one, we know almost every angle except for this one. We know this is 98. We know this is 98. This is a quadrilateral, so I can find the sum of the interior angles of a quadrilateral. Also, this diagonal here is going to bisect this angle down here. So if this side is 47, this side is also 47 degrees. So let's see, 47 and 47 would be 94. So this angle is 94. This one's 98, this one's 98. And I just need to take the sum of the interior angles and subtract those numbers. So to find the sum of the interior angles of a quadrilateral, you use the formula n minus 2, the number of sides, minus 2 times 180. So 4 minus 2 times 180 is the same as 2 times 180, which is 360. And then we have to take 360 and we have to subtract 98, subtract another 98, and subtract a 94. Subtract those three angles and you'll be left with the measure of the fourth angle of your quadrilateral. And I'll let you finish that up. Minus 94. So subtract all of those and you'll end up with your answer. Okay, number 4 is kind of a fun one. It says that each square section in the iron railing contains 4 small kites. The figure shows the dimensions of one kite. What is the length of iron needed to outline one kite? So we just really need to know what is the perimeter of this figure. So to find the perimeter, we need to know what is this side, which will be the same as this, and plus this side, which is the same as this. So there's 2 of these short ones, and there's 2 of the long ones. So short, long, short, long. If we add all of those up together, we'll have the perimeter. Well, these diagonals are crossing at right angles, so what we have is 4 right triangles. We also know that the length from here to here is 7, and the length from here to here is also 7. So we have a right triangle, this is to find the short, with 7 here and 7 here. So to find the hypotenuse, you can use the Pythagorean theorem, or you can use the fact that this must be a 45, 45, 90 triangle since the legs are the same, and we will get that this is 7 square root of 2. Now you can do that with the Pythagorean theorem if you'd prefer, or you can use the special right triangles that we learned about. That's an S. So that would be 49 plus 49, which is 49 times, I'm just going to leave it as 49 times 2, because then we're going to take the square root of both sides to get S, and the square root of 49 is 7, so we'd get 7 square root of 2. So we've got, so far with our perimeter, we have 7 times the square root of 2 plus 7 times the square root of 2, because we have 2 of those. Then we have to find the long side. Now I don't know a special right triangle for this, so I have to go 7 squared plus 17 squared will equal L squared. And, oh, not squared, just 49 plus, I don't know what 17 squared is. I should know this, but I don't off the top of my head. 289. 289. And then we will go ahead and add those together. Now, you may want to just find the decimal approximation of this, 338, which would be 18.38 once we take the square root of that. But I need 2 of those. So maybe I should at this point change this also to a decimal number. Or, you know, maybe I should figure out 338 divided by 2. Clear this out. 338, I want to see if there's a nice perfect square in here that I'm missing. Why do I keep hitting so many 3's? 338 divided by 2. Oh, 169, that's 13 times 13. Okay, so I'm going to change this to equals the square root of 169 times the square root of 2, because the square root of 169 is a nice perfect square of 13 square root of 2. So I need to add to this 2 of these, 13 square root of 2 plus 13 square root of 2. And then I add all of these together. And let's see, that would be 20 square root of 2, and that would be 20 square root of 2. So my whole answer would be 40 times the square root of 2 inches. Now you could definitely answer this as a decimal number. That would be totally fine. All right, the rest of the worksheet is not as tricky. So it was the first 4 problems that were the most work. In the rest of these, we're going to be using trapezoids. A regular trapezoid, just a non-special trapezoid, there's no good theorems that go with it. We have 1 pair of parallel lines, and that's about it. That's about all we can do. But if it's an isosceles trapezoid, then there's all kinds of theorems. Then we know the base angles are equal, both pairs of base angles are equal, and that these legs are congruent. So we can answer lots of questions. Also, the diagonals are congruent too. So in number 5, we need to find the measure of angle J. And we can do this because the measure of angle J will be equal to the measure of angle M. And because these are parallel lines cut by a transversal, the same side interior angles are supplementary. So 124 plus the measure of angle M is equal to 180. And once you find the measure of angle M, it's going to be congruent to the measure of angle J, so we will also know that one's measure. In number 6, remember that diagonals are congruent. So let's see, we know that FH, where's FH? FH is 9. And we're looking for AG. We're looking for a part of a diagonal. We know this piece of it is 6.2, and we are looking for this part. But we know that the whole thing is equal to 9. So you just have to go 6.2 plus, I'm just going to call it x, is equal to 9. And just solve for that. So I told you these ones won't be as tricky. There's some more problems. This says to find each value so that the trapezoid will be isosceles, so that you can use those theorems. In number 7, base angles will be equal. So 5x squared plus 32 will be equal to 7x squared. Now don't let the x squared make you think that this is going to be tricky, because there's no x term. So we're just going to go ahead. These are like terms, so I'll subtract 5x squared from both sides and get 2x squared. Now here's one thing to remember. When you take the square root of both sides, because it's x squared, so that's how we're going to have to solve it. When you take the square root, whoops, I'm sorry, I moved my screen and now it's probably, hopefully not, oh, all lost. Where's my work? There we go. Okay, I'm going to take the square root of both sides. I'm apparently pushing a button or something to make this jump around so much. Sorry, I really don't know what it's doing. When you take the square root of both sides, the square root of 16 is 4, but it's also negative 4. There will be 2 answers to this problem. There will be 4 and negative 4. There's 2 other problems on this worksheet in which you will get 2 answers. So if you have an x squared in your problem and you end up having to take the square root of it to find an answer, then remember that there will be 2 solutions to your problem. This also is going to happen in number 14, because there's an x squared, and in number 16. So both of those are going to have 2 solutions. All right, so the rest of it, I think you'll be able to figure it out by looking at the problems and the examples. If you have any questions, please let me know. 9, 10, 11, 12 are mid-segment questions, so make sure you look at the theorem about that.